Welcome to the Excode Week 1 workshop. This week, we've seen various concepts and we're going to apply now them in the workshop, such as print statement, conceptual programs, comments, and developer mindset tools such as decomposition and abstraction. So let's get started. You can open the Colab for the workshop, and the first activity is introducing yourself to the code. If you're remotely or in YouTube, just add a comment, put your name and why you want to learn to code. Your first exercise of the day is called your first lines of codes. In there, you're going to write first your name in a print statement, and then printing the sentence, "Nice to meet you." You can directly write the code here, where you can see start coding. Then you're going to print the name of the person sitting next to you or a friend, and then add a comment next to that saying your new Excode friend. That is part 1. Continuing, you are expected to write your first simple computer program taken from the lecture, which is converting temperatures. So you have to take a temperature in Fahrenheit and convert it to Celsius inside of a print statement. So you should do so in a single line of a print statement. You can see if you, for instance, you put print 5 plus 5, it will output directly 10. So here, if you write a print statement, you add some mathematics, just addition, subtraction, multiplication, or division, with the goal of converting 100 Fahrenheit and getting as output the corresponding temperature in Celsius. Be careful though, because there is something you will need to think at in order to get it correctly. Continuing, after this coding part, you're expected to do a more conceptual exercise, which is about conceptual program, divided into 2 sides. First of all, the first 5, which are more manageable, and then 5 which are more abstract. For each one of these, we don't expect you to write a code. Just take pen and paper or just talk with a friend and try to think about how these programs work from a really conceptual level. What comes in? What can be the type of processing? What is the output? And also try to think about the edge cases. What happens if there is a problem? What happens if in the temperature someone writes 0? What happens if in a specific food ordering system, the person never actually pays? And this way you can think about the various possibilities and the various ways you can map the input and output in order to create functioning computer programs. Once you're happy with your results and are really a right or wrong answer, the idea is more to get you to think around this. You can also keep it up and apply it to your own life. So for next week, just think about other situations, or when you open an app, think, oh wow, how is this working? What is behind the screen? A bit the magic behind the screen. Finally, the last activity is around the developer mindset. You can see there are 2 maps of London, the first one and the second one. And to look at abstraction, you should answer what is the differences between these 2 maps, as long as asking the reason for those differences, and as developers, the takeaways we can have from those differences. This is one of the core concepts in programming, and that's why it is really important for you to try and understand the fundamental reasons of why this happens and how we can apply this to programming. Continuing with decomposition, similar ideas, taking 2 stations on the map that are really far away, and how can we make that journey much simpler for us to manage from a conceptual point of view. And then how can I split it up into smaller parts, and as developers, what can we take away from decomposition, this example. Finally, as a take-home optional activity, you can also look at apps or one dream app or one dream project that you'd like to bring forward and try to think about what are the inputs, processing, and output you need to create it. Thank you very much for your time, and after this there will be the solution of the workshops. And I'll see you next week. Welcome to the Excode Week 1 workshop solutions. In this session, we're going to correct every exercise of the workshop, starting with your first lines of code. You can see print your name. My name is Lorenzo, so I just wrote here print. Don't forget the brackets and make sure you are using lowercase for print, and then you can put Lorenzo. Same thing for print nice to meet you. And for the name of your friend, it's the same thing, while for the comment, remember to add an hashtag. The hashtag is effectively communicating to the computer, ignore everything that is after it. Now, computer program, we have our code, Fahrenheit conversion. Here, I hope most of you got it. You need the parentheses actually, because if you only add the division is going to be run first, thus creating a problem. We're just applying concept from mathematics that we also need here in programming, and that also makes sense, such as using the brackets. Quite simple, just 100 minus 32, the brackets, division 1.8. And if you run this, you'll get 37.7, which is the correct answer in Celsius. Regarding the program system, there is not really a right or wrong answer as said. We can look at some of those. The temperature converter we just seen. The input, the temperature in Fahrenheit that comes in, the processing, the math such as the division, subtraction, and then the output is the temperature in Celsius. For print hello world, there's basically no variable input. It's just going to be always hello world. There's no processing as well, just displaying, and the output is hello world. This is quite a simple program. Continuing, if someone is allowed to drink, this is where conceptually we need to think of something called a conditional. Well, if you are over 18, then you're allowed to drink. If you're under 18, then you're not allowed to drink, depending on the country. We could have a check also for the country, but in UK, that is how it will work. So still at a conceptual level, the input will be the age of the person, maybe also the country. The processing is we're checking, is it over or under 18? And then the output is printing, yes, you can drink, or printing, no, you can't drink. Another example is rock, paper, scissors with 2 players. In this case, you did multiple inputs. The inputs can be what player A and B put. The processing is calculating who wins, so depending on what they play, you get a winner or the other, and the output will be printing the name of the winner. Guess the number game with higher or lower tips will also get as an input both the correct number, maybe randomly generated by the computer, and a second input, the guess by the user. We then have a processing, so we compare them, and then as an output, we have 3 possibilities. Either your number is higher, either is lower, or either it's correct. Then more abstract programs. These are programs where it's really complex, and we're not expecting you to fully map those. It's more looking at how can it work. For instance, a food ordering system, a type of input will be what food needs, what the customer, what food do they have? Have they paid? Are they paying? From what restaurant they're ordering? Are they doing priority delivery or not? Do they need cutlery? These are all type of things the customer may ask him. The processing, well, we need to match the client with a restaurant and then match them up, ask the restaurant, can you do it? So there's another input inside of the processing. If the restaurant accepts, we come back to the client, we have an output which is saying yes, he will do it. And the final output after all of this, the driver and delivering the actual food. Sending a message on Instagram. Also, you're going to need to get the message as input, you're going to need to encrypt it, and you're going to need to put it displayed on the phone of the people that receives the message. A library book borrowing system. In this case, you need probably to check, is the book available to be booked? And then you have to change it on the system once the person borrows it to display it's already borrowed, someone else cannot take it. So every time you want to take a new book, you will check, is it available? If so, you can take it as an output. You can say, yes, I can take it or not. An ATM cash withdrawal would also function similarly. When as input, it gets the quantity of money and the bank account. You check if there is actually the money in the ATM, if there's the money in the bank account. Probably does a lot more complex checks. And as output, gives you the money. And as succeed. Or gives an error. Finally, a car. Car is also quite complex. Car have plenty of inputs, especially self-driving car, where they will have maybe LiDAR or other types of sensors. As input, they may also collect the velocity, the type of movements you're giving to the car. And as output, you'll get the physical properties. So where is it moving, in which direction, to what speed, and more. Finally, correcting the last bit, the developer mindset, we can look at abstraction and decomposition. You can let me scroll. Starting with abstraction. What are the differences between the two maps? So if you remember correctly, the first map was a map of all the streets in London, while the second map was just about tube. The reason we have a difference between those two is that if I have to take the tube, I actually don't need all those useless information of every single street. I just care about where the tube goes. And that's what abstraction is so important. Abstraction is about removing the useless to only keeping what actually matters, making abstraction of what does not matter to keep what is the most important. And the reason of these differences is that I only need those things that I care about. This is really important as a developer kind of tool set that we can use in plenty of problems and that you will use in the next couple of weeks, because they allow us to see, oh wait, the problem is really complex, there's a lot of input, I'm lost. But no, actually, let me take a second, deep breath, maybe ask my workshop leader, and look at it from a different perspective and realize that I can actually remove all of these inputs, care about them later on or not care about them, keep what actually matters, then bring it up, solve it at a higher level, and then go back down when I'm much more relaxed and I understand more the actual solution. Then decomposition. When I have to move from two wildly different points on the tube, I can, just looking at it, maybe remember every single turn and every single movement and every single change I have to do. So what I'll do is I'll break it down into much more solvable and simple problems and situations that I can then solve individually and then put them back together. So from A, I go to B, from B to C, from C to D, and then finally I'm arriving at E. So that is what decomposition is. Splitting up and breaking down, decomposing a really complex problem to make it simpler because of smaller, more solvable parts. Finally, the take-home activity. There was no right or wrong answer, and I'll see you next week when you can present it. Thank you.